Imagine going to a park and see a circular pond in a 15 times 15 yard grass area. The pond is located from the bottom left corner 7 feet up and 6 feet over. If the grass area was a graph with the bottom left corner being the origin, what would the circle equation be?
We're explaining the derivation and the use of the circle equation. First of all, the definition of the circle is a round plane figure whose circumference consists of points equidistant from a fixed point defined as the center. The circle equation is x minus h squared plus y minus k squared equals r squared, and r is the radius. By using the Pythagorean theorem, we can find the radius in terms of a squared plus b squared equals c squared, where a is x minus h, b is y minus k, and c is the radius. We can use a right triangle like in this, because according to the Pythagorean theorem formula, you can find the hypotenuse, which in this case is r, by saying a squared plus b squared equals c squared, which in this case is the radius. The points x and y represent any points in the circumference of the circle, so they could also be here or wherever in the circumference of the circle. H and k represent the center of the circle. For the x value, you say h, and for the y value, you say k. A is x minus h, because the distance from x to the x-axis minus the distance from h to the x-axis equals the length of A. And to find the measure of B, we do B is y minus k, because the distance from the y-axis to y minus from the y-axis to k equals B. So this minus this equals this, which is B. If a squared plus b squared equals radius squared, then 4 squared, because this is 4, plus 5 2/3 squared, because this is 5 2/3, equals the radius. Any coordinate on the circumference of the circle could be plugged in instead of x or y, and the same for h and k to find the radius.
We can use the circle equation to find the radius of a circle. For instance, if you have the coordinates 4, -1 as the center of your circle, and you know that a point on the circumference is 8.2, you can determine the radius by using the circle equation. We know that the circle equation is x minus h squared plus y minus k squared is equal to the radius squared. An example of how to use it is when we use the coordinates from above. We know that 8,2 is on the circumference, so if we plug it into the circle equation, we get 8 minus 4 squared plus 2 plus 1 squared is equal to the radius squared. It's plus 1 because -1 times negative is equal to plus. Next, we distribute, so we get 4 squared plus 3 squared is equal to the radius squared. 4 squared is 16, and 3 squared is 9, so 16 plus 9 is equal to the radius squared, which is equal to 25. We find the square root of 25 because r is squared, and that is equal to 5. So in this example, the radius is equal to 5. To test if the radius is the same all around, which means that all points on the circumference are equidistant to the center, we can use distance formula. This will prove our circle equation conjecture right.
The distance formula is ab squared equals x2 minus x1 squared plus y2 minus y1 squared.
In this formula, a and b represent two different points, and x2 and y2 represent the coordinates of A, while x1 and y1 represent the coordinates of B. We're going to say that AB is CA, where C is the center and A is the circumference. We're going to use the point 4, 4 on the circumference, but it could be any other point. And, 4 from the here, minus 4, which is the center, squared, plus 4 plus 1 squared, because it's negative, and negative, which equals a positive, is equal to the square root of 5 squared, which is equal to the square root of 25, which is equal to 5. Another example is when we use 8, -4. So we say 8 minus 4 squared plus -4 plus 1 squared, which is equal to 4 squared plus -3 squared, which is equal to 16 plus 9, And we had the square root around it the whole time, so we say the square root of 25, which is also equal to 5.
The distance from C to A, which is any point on the circumference, is the square root of x2 minus x1 squared plus y2 minus y1 squared. For a circle, CA is the radius, so the radius squared is x2 minus x1 squared plus y2 minus y1 squared. The x2 is x of a point on the circumference, and y2 is the y-coordinate. x1 and y1 are the coordinates of the center C. We can replace x1 and y1 with h and k. Now we don't need to write the sub 2 on the x and y on the circumference.
The circle equation is really just the distance formula with all the variables. R squared is the same as AB squared. X is corresponding to x2, h is corresponding to x1, y is corresponding to y2, and k is corresponding to y1.